Hello and welcome back to this course, covering the exam topics for the JNCIS-SP certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in JNCIS. In this video, we'll be taking a look at the first two bridging mechanisms in more detail: learning and forwarding. See, learning which port a MAC address can be reached on is essentially the switch's overall purpose for existing. It's one job. This is what they were made for. So, let's jump right on in. When a switch receives a frame, the very first thing it does is inspects the source MAC address of the frame so it can record the interface that source MAC address was seen on. This information is recorded in the bridging table, the same very table that's used for looking up which port to forward frames out of to reach the destination address. Here, we have fields of an Ethernet frame header. The destination address and source address are located in the beginning, directly after the preamble. The preamble is just a sequence of alternating ones and zeros to help the device identify the start of the Ethernet frame. By default, the switch will inspect the source address and record it, along with the ingress interface, to the bridge table, like this table here. We can see our bridge table has 3 entries, with a single MAC address seen on each of 3 interfaces. It's possible, though, that you may have a use case for wanting to disable the learning mechanism on some or all ports of your switch. This can be accomplished with the No MAC Learning configuration statement under the Switch Options configuration hierarchy of the port you want to disable the mechanism on. This could be useful in a situation where you expect a single MAC address to often move between ports, or if your application requires flooding of data to all connected devices without the use of a higher-level protocol. The forwarding mechanism allows a switch to, forward traffic. After the source MAC address is inspected and recorded as part of the learning mechanism, the next thing the switch will do is inspect the destination address. A lookup on the bridge table is performed with the destination address. If an entry is present on the table, then the frame is forwarded out the port associated with that address in the table. Now, you may wonder how a switch then handles forwarding when multiple VLANs are involved. What happens when the destination MAC address is in a different VLAN than the one the frame was received on? The answer to this line of thinking is that the bridge table doesn't only contain MAC addresses with associated interfaces. It also contains the VLAN on which that port and address association were seen. As we know, VLANs are logical separations of broadcast domains. The switch will organize the bridge table by which VLAN the MAC and interface pairs are associated with, and only perform a lookup against the VLAN the frame was received on. This ensures frames do not cross broadcast domains at a Layer 2 device. It's a Layer 3 device's responsibility to route packets between broadcast domains. I appreciate you working through this with me. In the following lecture, we'll take a closer look at the remaining bridging mechanisms. I hope that this lesson has been informative for you, and I would like to thank you for viewing.